Hi everyone, welcome to my talk, Pure Functions and Immutable Objects. Let's see. My name is Rentea. I'm a Java champion in Romania, and I'm deeply in love with simple design, refactoring, and unit testing. That's what I love doing most, and that's actually the focus of the community that I founded, which is now one of the largest in Romania, because software craftsmanship community. You can find us on Meetup if you want to join. I do all sorts of free webinars there. My best talks that I gave until now, goodies and a blog, you can find on my website there. I'm also, what I do for a living, I'm actually an independent trainer and consultant. Starting April, I am doing this full time, providing training for different companies. So 8 years ago I started doing that, and up until now thousands of developers have attended my trainings in dozens of companies. My comfort zone, of course, is Java world with Spring Hibernate functional programming, but my most wanted topics actually are design patterns, clean code, and unit testing, and I do this in many languages. Of course, Reactivex became more and more demanded these days, and Java performance is very good training. In case you are interested for a session for yourself or for your company, check out my website. There are details there on how to join. You can also follow me on the social media. I'm posting stuff regularly. Good. So let's talk about life. How is life? How is developer life? Now, did it ever happen to you that you inverted the order of two lines in your code and suddenly you had a bug because of that? There's actually, there's a name for this. It's called temporal coupling. When the order of two instructions starts to matter, it means that they are somehow interrelated. Or did it ever happen to you that a method that you called ended up that it changed the parameter that you gave it, such as that? So customer set active true. Would you expect that the method named check customer will activate the customer? Well, 14 years ago, I didn't expect that. Right? No one foresees that. It's unintuitive. Do you have tests full of mocks? Do you have tests in which you need to mock 5 or more dependencies in order to bring a piece of functionality under tests? Did you ever have a race bug, a multi-threading error in your code? People say that the childhood ends when you have your first multi-threading bug, like a race bug. Did you ever have different results for the same input? Did you ever search for a flight on a low-cost airline and you got a larger quotation, a larger price the second time you searched for that very same flight? Did it ever happen to you? Now, how did it feel that you saw a higher price 10 minutes after? I mean, it's frustrating, right? So these all are signs of impure functions. Now, 28, in 94, a smart guy had this idea to separate somehow the functions which are commands from those which are queries. Now, a command function returns void. Now, tell me, why would you call a function that returns void? Well, I'm sure that not for the result value, right? So you will call this function for it to do some side effects of some sort, to change stuff in the world, right? Whereas a query will give you results back. Now, most developers will not expect that if you search by the same criteria, you might get different results back. Or if you ask the price twice for the same movie, you will get a different result back. People don't expect these will return different results. That's why the command query separation tells that these should be pure functions. Now, what are pure functions? Now, pure function doesn't do any side effect, doesn't change anything, doesn't do any database insert or HTTP post. No queues, no files, not even changing a field is allowed from a pure function. Now, a pure function will also give you the same result if it's given the same arguments. And this is called, this means that you should not rely on the current time or random or even on data that is brought from an external system like a database or an API. You should not rely that the same data, the next time you call the API, different data might come in. So this is called referential transparent, if you want the official name for that. Right? Now, the simplest way you can think of pure functions is as mathematical functions. A pure function is exactly a mathematical function which produces results based on inputs, and nothing changes if you call this function twice in mathematics, right? Now, there is a common confusion between referential transparency and idempotency, and I want to spend a minute on this. Now, referential transparent really means that if f of 1, 2 equals 3, then you can safely replace f12 with 3 everywhere where it occurs. So I can safely overwrite f2 with 3 everywhere. Simple as that. Now, in contrast, an idempotent function, it means that after you call f once, calling it again, many times again, will not produce any extra changes. The vase won't break again if it's already broken. So delete from x where id equals, this SQL is actually idempotent because deleting it again will not produce any significant extra effect in the database. So in other words, an idempotent functions can do side effects, right? Whereas a referential transparent cannot. By replacing the function call with a number will effectively mean that there is no call happening for this function. Right? Now, just a quick quiz for you. Now, f1 given x returns x plus 1. Now, a minute to think. Okay, it returns results based on the inputs. Yeah, this should be pure. Yes, indeed. This is pure function. How about this one? Returns d.x plus. What the heck is that? It means that it increments the field x of d. So this means that certainly there's side effects out there, so this is not pure. How about this one? Well, d.increment x, where is d? It doesn't really matter where d comes from. What matters is that it is being changed. Increment x, you can expect that it does side effects. So because of that, f3 is not pure. How about this one? Well, querying an SQL, running a select in the database could feel like pure because it doesn't do any side effects. But unfortunately, this can bring you different results the next time you call it. So this is not referential transparent because the select might bring you different results the second time you call it. How about f5? Well, this.x plus y. X, I don't know where x comes from, but I is a parameter. This.x is a field of the current instance. Now, is f5 pure? Now, just think a bit. It really depends. It depends on whether x can change between two invocations of f5. So most people like to think of pure functions in a static context, right? Because you see in this example, x comes from the instance variable. The real question to ask to solve this problem is whether x can change between two invocations on the same object. Well, if the object this is immutable, then x cannot change, so it will give you the same results the next time you call it. So immutability, you can already see that plays nicely with pure functions. Otherwise, it might get into trouble if x changes between two invocations. How about this example? Well, d.getX plus y. Well, again, it's a field of d plus y. You might think it's similar to the previous example, but you might say this is not pure because x might change. But honestly, if x changes between two calls of f6, right, then it means that you get really a different d the next time you call f6. So it's a different input. So we are allowed to return different output if d is different. So, of course, in this reasoning, we assumed that the getter is pure. We assumed that getX doesn't increment x. So you see how important names are when you reason about pure functions. Now, of course, if you would increment x when you call getX, probably your team leader will just have your head for this. But f7, is this function pure? If I is negative, throw exception. Wait, what? Exceptions? Wait a second. Well, if you think of exceptions like normal, like a form of return value, then f7 is also pure, because it always throws for a negative I. So throwing an exception is pure in case you always throw it for the same inputs, like we had just previously. However, how about the catch? Is catching exceptions pure? Well, it depends. It depends. It depends on the exception that you catch. If the exception that you catch is always thrown for the given input, so is always thrown given the same x, then you can safely say this is pure function. But if you catch an IO exception or an out-of-memory error, then those can't be possibly foreseen. These are not dependent on the inputs. So your program execution might depend on things which are not coming from your input. So this will make your catch block impure. So this is yet another reason to catch the unexpected exceptions in the outskirts or the boundary of your code. Right? Now, why do we love pure functions? Because they are fair with us. They are honest functions. They don't rely on any hidden inputs with only plain sight parameters and return values. However, pay attention with instance functions. Easier to understand because of that, and easier to test. You don't need a lot of dependencies to test the pure functions. In theory, you shouldn't need any dependency to mock. Then they are fast and composable because if you understood it fully, you aren't really allowed to go outside of your GVM or of your process, right? So this will make them very fast and very easy to compose, as you will see in the next slide. There is no temporal coupling because there is no hidden relationship between two functions. A relationship between two functions will be expressed by the second function depending on the return value of the previous function. So the code will not compile if you swap the lines. And they are also very easy to parallelize since there is no temporal coupling and you can run them for free in as many threads you want. Now, if a function is both pure and fast, and as I said, they typically are fast, then it's safe to call it as many times you want. This enables two very powerful refactorings that I would like to sketch for you right now. Imagine you have this local variable data, which is equal to f of ab. Now, if f ab is pure, then you can safely inline the variable, destroy this line, and call the function twice wherever you needed that variable. So this is called replace temp variable with query in Martin Fowler's refactoring book. It's a very, very useful technique to have in your toolbar. And there is yet one more. If you call the f and then the result of f you pass to big function here, right? Then you can, if f is pure, you can inline the parameter. What? Yeah, you can inline the parameter and reduce the number of parameters, given that you have access to a and b inside big. But it's very, very frequent, it's very often you can do this, and it's very powerful because you can reduce the number of parameters of your method signature. Very interesting, because you can repeat the method as many times you like. I know what you're thinking now. Well. Okay, the function could be pure today, but what if tomorrow a developer, a colleague of mine, comes and does an insert in my function, or I don't know, calls a web service? Then the function will suddenly become impure. Yes, you are right. And if you did this refactorings and then f becomes impure, then it can have a bug. But it all comes down to whether you trust or not your colleagues. I mean, if you change f, I would expect you would also test the places where f is being used, right? So it's a matter of trust here. Again, yet another argument. The best clean code you can ever write assumes that you have trust in your colleagues. That's it. I'll make all my functions pure, right? Stop. That's usually impossible. Now, what kind of an application doesn't change anything? Although there are some kinds of applications out there that don't have any data store, most of us do need to change stuff. The bad news is that Java doesn't offer us any way to strictly check purity at compilation or runtime. There is no built-in check in the language. So we have to live with both pure and impure functions. So what do we do about that? How do we distinguish between the two types of functions? Because we could try to use this old principle, command query separation, but the reality is that in real life it's very hard to follow. There will be cases in which a function that computes stuff will also need to change stuff, right? And one workaround to that is to include the side effects in the name of that function, but this is a very weird technique. I mean, what? Compute price and adjust metrics? How about single responsibility principle? Aren't you doing two things at once? Actually. But so the point is, I'm sure we can do better than that. Let's try again. how do we distinguish between pure and impure functions? So let's start with this bunch of logic that you have to implement. This is your complex logic that you have to do. Now, I will ask you to isolate in the middle of that complex logic a core which is composed only of pure functions. I will call it the functional core. And then I will ask you to push all the side effects and non-deterministic reads outside in the imperative shell, in the surrounding code, right? In other words, make sure that any write or a non-deterministic read becomes visible at the exterior of your code, should be exposed, such that you can purify the most complex part, the inner part of your logic. What's that? How do I do that? Well, time and random, for lack of time, I will skip this slide. Typically, relying on time and random doesn't give us a lot of headaches in applications. Avoiding to use files in the middle of your core logic, I think it's common sense for all of us, right? Separation by layers of abstraction. You shouldn't interact with files in the middle of your workflow. It should be outside. But what's most painful to this attempt to purify logic is the database and API calls that we do. Now, if those database or these reads are performed at the beginning of your workflow, I would suggest you that you do the queries or the API calls, and then you get the data back and you pass the data as a parameter. Avoid querying from inside the complex logic. Okay, this will allow F to become pure. Okay, and the orange part, the surrounding code, will do the reads and then pass the necessary data inside. Most workflows at the end of their execution need to write something to the database or to some API. If they need to do that, I will advise that you return those changes out and you persist or you apply them outside of your pure function, right? In the imperative shell. But these are a simple example, but how about a read which happens right in the middle of a workflow? So this is the functional core here, and suddenly in the middle of your function, you need to call stuff. You need to bring more data in. Now, what do you do then? Well, one thing you can do is a more elaborate refactoring, which is called split phase, which effectively means that you could split that big functions into two phases and introduce a data structure which moves between these two phases, such that you can bring the read up in the imperative shell. You can actually sectionate, you can cut that big logic into smaller pieces, call each them individually, such that the places, the dangerous parts, the read and writes to the outside world, are visible at the top level, out in the facade or in the higher level policy. Right? They should be visible there. Nice. This is how you can expose impurity related to database and API calls. But there is one more pain point. So, just summarize a bit. I want you to implement as much logic as internal pure functions, exposing impurity to the surface, right? The inner complex logic of your applications should be pure functions. Now, the worst part of, the worst and the most widespread way, the most common reason for a function not to be pure is when you change some objects, fields, for example, the state of some objects. Now, this inevitably gets us to immutable objects. Now, let's do a little code inspection session to see the life that expects us. So, if we want to investigate, to reason about this function f, and we want to figure out whether this line will run or not, how would you do that? You need to trace what's the value of x in data. So you need to trace where data came from. It came from G. And then in turn it came from H. And there at H, the x had value 1. So apparently this should run if you execute the code. Unfortunately, because data is mutable, okay? Unfortunately, along the path, someone updated the x field with a setter. Very easy, right? So, bang, you need to trace wherever the set is called, the setters are called. But that's not all. Sometimes you will pass the data instance to another function, and that function will change the field. So you see, you no longer need to trace the path that the object came to you, but you also need to trace all the places in which the objects ended up passed to. Ouch. And there is yet one more, this is a very common scenario. And there is one more, less common but completely evil scenario that can happen. You can call a function on an object without passing the data instance. But however, this object might keep a reference to that same instance, with reference that it got several seconds ago. Right? You just set the data in here in a field, and then on the same object you call muted field, but without passing anything. And because because object instance had kept a reference to that same instance, it can change the instance. My God, how evil this is! Right? So in other words, you need to figure out what code ever ran before your if, having a reference to that same object on heap. This is insane. This is like, you need to scan the entire stuff that happened before you, right? This is another example of why long-lived mutable data are painful to work with, okay? Now, let's see what happens if we turn data into an immutable object. If data is immutable, you don't have setters, you can't change the field. So the setters disappear. Immediately after, you realize you don't actually need to trace where this instance went to, because I can't change it anywhere, anyway. So this will actually remove all this complexity, and will just have you look at where this instance was originally created. Right? A quick tip for you in case you're using IntelliJ: there is a nice analysis option there, which is called Analyze Data Flow to Here. Google this one. It's brilliant in large code bases. Now, so immutable data are a lot more comfortable to use in large workflows, wherever data travels a lot of time, a lot of code. So the only question you need to ask in this case is, who created my instance? Now, in the real world scenario, this is very important, because the length of our workflows sometimes is quite long with many functions calls. So you don't want to be tracing everywhere where the instance got to. You want to be certain that the data didn't change. Now, a quick glimpse of how an immutable class might look. Initially, I wanted to write code with you, but since I have so much things to tell you, I decided to put all the code on a slide and walk through it with you now. Of course, it's common sense that the fields should be final, right? Should be changeable, although that's not strictly required. Okay, and this trick. Removing the final keyword without adding setters actually will enable us to persist these objects with Hibernate in a relational database. But it's a bit out of scope for this talk today. Now, in case A is supposed to be immutable, then so should B. Otherwise, you might change stuff inside B. So you see, this is the difference between shallow and deep immutability. A deep immutable object A will ask from B to be also immutable. Now, collections are painful in immutable objects, as you will see right now. If these are final fields, you need to take them to the constructor, but if you take to the constructor a list, you need to clone the list. Why? Because then the creator of your object, the one who calls the constructor, might keep a reference to the same collection and change it afterwards. Right? In theory, by the book, this is required, but in practice, this is overkill. The problem is not the one who created the object, but the path that object traverses. The problem is not in the H function, but in the 7 functions in between between H and F. This is where the problem is, on the path. So in practice, it doesn't pay to clone the array like this. It's a waste of memory if you think of it. Then, if you've managed to create immutable objects, then it's even better if you validate them at creation moment, because this will guarantee that your objects are always consistent, are always correct. Very powerful technique, although it might hurt you a bit on the testing side. Then the getters, of course, you shouldn't expose the list inside, because this will allow anyone outside to change your list, but you should give them decorators on top of your list that will block any attempt to remove or add or change somehow the list. There are two other geek options that you can try out. Do try these out. They are quite interesting. Iterable will allow you to do a for on that, and this will allow you to do contains, for example. There is a third option, returning a stream of strings. Anyway, hash code equals on all fields. If you do that, you will effectively build what's called a value object. More on that in a later talk. But if you want final fields, constructor, getters, and hash code equals, then you would be happy to find out that Java 15 with the records will get you all this for free. Until then, we will resign ourselves with Lombok value until we get to Java 15. So I guess most companies will wait at 1.5 years yet until they will jump to Java 17 next LTS. So until then, Java Lombok value is just good for us. And then you can add more logic to these immutable objects, right? When I teach immutable objects, many of my training groups tell me, oh, I need to put final on the class. And my question is, why? Are you afraid that a colleague will overwrite or subclass A? Don't they know it's bad practice to subclass concrete classes? Don't they know that? Why are you afraid of your colleagues? Okay, if you want to change the state inside A, the only way you can do that is by creating a new instance. This is a wither that you can write that will create a new object, having a new string, but the old values inside. Cool. So we can actually somehow mutate those objects. And this guy has an idea. I know what I'll do. Every time I change the object, I will return it back. Okay, and I'll do it every time. Perfect. Now imagine that this data object has 20 fields. If it has 20 fields, who changed the field? The question will be still there. Who changed the field? You need to trace in all these functions, and you need to walk through all of them to find out who changed X. You see, the mess is still here. That's the bad news. That's why this is a bad practice. The real reason why this is bad is because the object is too big. The real problem is that the data has too many fields. Now, one brutal solution to this problem is to make your variables final, right? Now, I like the fact that IntelliJ will highlight any variable that you reassign inside the function. And I will use this hint to avoid these. But the brutal solution is to mark data, any local variables, as final. This is the brutal solution, but the real problem to this, in this case, is that your immutable objects are too big, are too large. You should have smaller objects. And I'll tell you what you can do. You can group X, Y, and Z. Right? You may want to group these three fields in a single little new value object, new immutable objects, like this. And instead of progressively getting the X set up, Y set up, and Z set up, you can call a single function that returns to the X, Y, Z. But this will require a new object to create. Right? Still, this guy has another idea. Passing it an array and changing the array. Oh my god. Do you see what this guy is doing? He's reassigning a parameter. This is completely wrong. You will say, oh, we don't use arrays, we use lists. Okay. What does this do? It will change the argument that you're given. It will change the list of your caller. It will remove stuff from it. Well, this is no. The last one is the most horrible example I ever saw. Map get one. It will get the immutable object from the key 1. It will change it, change the X of it, and then put it back on the same key 1. You see, this is completely wrong. This is like, oh my God, the panic moment, right? So please don't ever change collections. Java allows us to do this. Java is an old language. Don't mutate collections. Take advantage of the Java 8 Stream API and then go ahead and create new collections. Filter map. And this is, in this example in particular, filter map, and then return the new collection. Right? So why do we love immutable objects? Because they are easier to trace where the changes happened. They can enforce validation in their constructor. And they are also thread safe because you can't possibly have any erase bugs. Since you can't change immutable objects, any number of threads can read from them simultaneously. I don't care. Nothing can go wrong. All right. So from now on, only immutable objects. I've worked with, I think, almost 50 companies until now. There is only one single company that I heard, that I know, they are using fully immutable data structures for their persisting data. This is not possible for most cases, especially for Hibernate or ORM. So don't try to make the whole entity model immutable. This is not the goal. Instead, extract immutable little objects, immutable objects from them, leaving the root entity mutable object. So for example, my root entity is a mutable data structure, but the little various bits of data inside that big entity will be represented as immutable objects. For example, imagine a full name class, which is immutable, and it's kept in a field of this entity. Now, if you wonder how do you do this with Hibernate, then the embeddable annotation will allow you to do it. So practically speaking, you will then try to continuously decompose larger entities into smaller such persistent leaves and then make them immutable in turn. This is how you use immutable objects in day-to-day life. Oh, and there is one more. There is one more use case, very powerful use case for immutable objects. I wanted that, besides persisting data, there are other kinds of objects out there, like runtime objects, objects that carry data throughout various workflows in your application. I want you to make all of those runtime, non-persistent objects, I want you to make those immutable. Make them immutable and write logic on immutable objects. You know, the big deal of immutable objects is that it allows you to ensure that those objects do not change along long code workflows. So imagine you call A, which calls other functions, and in the end, deep down in here, someone updates a field. Immutable objects allow you to block this, to interdict this. So what I want you to do instead is to surface the change, to compute the change in here, and then return the value out, up until here, in which, in the imperative shell, remember, in the imperative shell, and in the imperative shell you apply the change on the entity, right? And in order to make sure that all of these remain pure functions, one way to do it is to make sure you pass only immutable objects through your long workflows. So again, immutable objects are for long workflows. This is where they pay off. This is where you get most benefit from them, right? Immutable arguments and immutable return values, right? This is how we want to do it. But what if you want to change simultaneously many fields of your entity? What do you do then? If you just start reading a bit about functional programming, you will quickly run into these tuple concepts. And you might think of returning a string and an integer. So right from here, you will return two strings and an integer, up until here. But this is just duct tape, in my opinion. I want you to be bold enough and try to search for a name for a new class that will represent what that string integer are really meaning, right? And you have my respect if you can find the good. I know how hard this is in applications with class names composed of 6 words. I've been there. I know how difficult this is. But if you can pinpoint a concept that will represent, to put a name to these 3 primitives, then the best for your application. So the big deal with immutable objects is when they traverse lots of code. And now some of are asking, what about performance? concerned about performance, measure it. You might have a surprise. You might have a surprise because the garbage collector has no problems evicting such little immutable objects when they are not referenced. They get cleaned up in the young minor collection. They're immediately painless. However, you should avoid immutable objects. If you do trash millions of instances per second, like insane, right? If you clone lists, immutable objects and collections don't quite work that good in Java. In Clojure, that's another story, the state-of-the-art collection framework there. But in Java, immutable objects that have collections inside might be tricky to work with. Trivial logic don't deserve immutable objects. Trivial logic, I don't care. You can set a field, set it. I don't care. I care about those long workflows going through 7, 8, 10 deep functions. Then don't make your entities or your data transfer objects immutable entirely. It's too painful. And DTOs, those that are sent and received as JSON, they don't deserve to be immutable because they live only a short amount of time. You don't really write logic on those data transfer objects, right? So, wrapping it up, takeaways. Anytime you have some complex logic, try to implement as much of that as pure functions that manipulate immutable objects. Then cluster those pure functions in a functional core, pushing anything impure in the imperative shell, like database calls and remote API calls. Take them out, make them visible. At the top level, they should be there. Instead of changing stuff in there, compute new objects and return them. And again, without proper mindset, immutability can do more harm than good. Remember, don't mutate variables, local variables. Don't change collections and don't change the state of the object that you are given as parameters. And then for immutable objects, they are most valuable when they are used for runtime data that moves through lots of code and also as persistent leaves in your immutable data structures. So in one word, instead of changing stuff in there, compute and return the change. Thank you very much for your attention. In case you want to know more about me and follow me, there's my website. Thanks, and I'm open for questions.